In this video, I'm going to show you how to do number 10 from that purple paper for chapter 4. Number 10 says 25 milliliters of a 0.1 molar hydroboric acid solution is titrated with a 0.2 molar sodium hydroxide solution. How many milliliters of the sodium hydroxide solution are required to reach the equivalence point? So we're going to start by highlighting our important information. And there's, again, a lot of information in this question. So let's really break it down. Titration means that we're having an acid-base reaction. So we have this acid, hydrobromic acid, and we have this base, sodium hydroxide, and we are mixing them together. So our chemical reaction is as follows. Hydrobromic acid plus sodium hydroxide becomes water and sodium bromide. And we want to reach the equivalence point. So this means we want to neutralize this solution. So we want to fully react all of the hydrobromic acid. So we need to figure out how much hydrobromic acid we have. We are given milliliters and we are given molarity. So from those two pieces of information, we can calculate the moles of hydrobromic acid. So molarity equals our moles divided by liters. So we will have 0.100 molar equals our X moles, which is what we're trying to figure out, divided by and 25 milliliters becomes 1, 2, 3. You divide by 1,000, 0.025 liters. So when we solve for our X moles, we should get 0.00250 moles, and that's of hydrobromic acid. So now we have our moles of hydrobromic acid. So we have our moles of hydrobromic acid, and we need to know how many moles of sodium hydroxide will fully react with hydrobromic acid. Once we have our moles of sodium hydroxide, since we have the molarity of our sodium hydroxide solution, we can figure out the number of milliliters. So we're going to take our moles of hydrobromic acid and we will convert it into moles of sodium hydroxide. So moles of hydrobromic acid go on the bottom, moles of sodium hydroxide go on top. And notice in this balanced reaction, it is a 1-to-1 mole ratio. So now that we have our moles, actually I'm going to do this in two separate steps. So calculate your moles of sodium hydroxide, which are actually the same because it's a 1-to-1 ratio. And now that we have our moles of sodium hydroxide, we can figure out our milliliters using our molarity equation. Molarity equals moles over liter. So we're given 0.200 molar of NaOH. And that's going to equal our 0.0025 moles of NaOH all over our liters, our X liters, which is what we want to figure out. So we do some cross multiplication, and we should get 0.0125 liters of NaOH. Okay, notice there are 3 significant figures, 4 significant figures, so our answer needs to have 3 significant figures, the lower number. And also notice we are given milliliters, we are asked for it in milliliters, so we need to change this into milliliters, which would be 12.5 milliliters of NaOH. So that is our solution, our answer.